Hi, Michaela. Thanks for sending us in your question about finding the absolute extrema of a function on a closed interval. For that type of problem, you always want to use what's called the closed interval method. Okay. Now, to do the closed interval method, you want to find the derivative of f. So I've written out f of x. I'm going to find the derivative, and hopefully by now in the year you know how to find derivative. But it'll be 6x squared plus 6x minus 12. Okay, and then we got to find the critical values. So the critical values occur where the derivative is either undefined or 0. Okay, this will never be undefined for many reasons, but there's no denominator for one, and there's no square roots or anything like that. So we only have to worry about where it's equal to 0. Okay, so I'm going to take out a 6 here, x squared plus x minus 2, and then we're going to factor to find our critical values. So this is x plus 2, x minus 1. Okay, so our critical values, I'll call them CVs, are -2 and 1. Okay, so what we want to do now is the closed interval method says that you can plug in your critical values and your endpoints. These are both x values right here. So we want to plug in our critical values and our endpoints. I'm going to do them in order: -3, -2, 1, and 3. Okay, so now we plug these into the original function here. Okay, so we'll get, let's see here, I'll do some scratch work over here. 2 times -27 is -54. And then plus 27 plus 36 plus 1. Okay, so that's -27 plus 36, which is 9, plus 1 is 10. Hopefully I got all that math right. -2, so we get 2 times -8 is -16. 4 times 3 is 12. And then plus 24 plus 1. Okay, so that'll be, see, -4, so 21. Okay, plug in 1. That's an easier one. 2 plus 3 minus 12 plus 1. 5 minus 12, -7, -6. Okay, 3. So we get 54 plus 27 minus 36 plus 1. Okay, so 54, let's see here, 54, 84 minus 81 minus 36. I'm going to go ahead and write that out. You get 11, 5, 7 minus 3 is 45, plus 1 is 46. Okay, so therefore, now you look at the y values and see which one's the biggest y value. So clearly 46 is the biggest. So then that tells us that there is an absolute maximum at x equals 3, because 46 is the largest of these y values. And it's because -6 here is the smallest of these y values. There's an absolute minimum at x equals 1. Okay, and that's what I believe they're asking for in this problem. Alrighty, and you can have, just so you know, you can have 2 maximums or 2 minimums. If, say, you got another number, say I plugged in 5, and that was in this interval, or let's make it better. Say I plugged in 2 and got 46 as well, then there would be 2 absolute maximums at x equals 2 and x equals 3. Alright, thanks for sending us in your problem, and we look forward to answering more of your questions.